Jeremy Haberman. I'm a software developer for Livefront. We focus on mobile development and design here in Minneapolis. I primarily focus on Android development. With me here is Brad Armstrong. He's the lead Android developer for Code 42. And today we're here to talk about RESTful implementation for architecture on Android. Now, back in December, Peter right here, Peter Pascale, the three of us are members of the Android user group, Minnesota, and actually Peter and Brad are the co-founders and organizers. And Peter had thrown out an idea because we didn't have a regular meeting scheduled for December. Like, hey, let's just get together, drink some beer, hack out a little code, have some fun, at least, not waste this one night a week, the one night a month that I've got reserved to escape my kids and my family, and just throwing out some ideas for what to work on. And a couple of us had seen this talk that was done at GoogleIO in 2010 by Virgil Dobjanschi about developing Android REST client applications. Great talk. It really opened my eyes to different ways of approaching problems that I had experienced with Android. But there was one problem, and it wasn't a surprise to anyone because Virgil specifically said, this is all abstract, pattern, theory. I'm not going to show you any code. The challenge was that it was such a new pattern and a specific pattern for implementing these concepts. Some of the things were given to you by the Android SDK, some of them weren't, and so there was a challenge of how to actually do this. And it wasn't just a problem that we were having. This is the top comment on the YouTube video of the talk. Where can we get some example source for this pattern? There were apps that people had suggested, but the pattern is hidden among the domain for that particular application, so it was tough to just pull out exactly what you were looking for. So we decided to take a stab at it. Little did we know that 3-hour hack fest at a local bar wasn't nearly enough to get anywhere with this. I don't even know if we wrote a line of code. It took us 3 hours just to figure out what we wanted to do. So we decided that we were going to start this project of developing an open source implementation of this pattern. So first, what does this pattern give you? Why does it add value? What problems does it solve? So just taking a step back, looking at the big picture, you've got some RESTful web API, some resources on it, and you've got a mobile app. And generally speaking, you just want to transfer the state of those resources from the web service down to your app. So you create an Android, you create a simple list activity for tweets, and you fire off an HTTP request to get those tweets from the API. But you're an Android beginner, and so you don't understand that you need to put this in a background thread, and so you immediately get this application not responding error. Now, the most common way, and it would often be the suggested way of tackling that problem, is to create a worker thread in the activity, typically in an async tab, so that HTTP communication is off the UI thread. It's happening in the background. You show a nice little spinner while it's happening. So we create that worker thread in the background. We fire off our request. We get the tweets back. We just display them in activity. We think everything's great because it seems to be working quite well. But the problem is these tweets are in memory, and so the next time that the user launches the activity, or maybe you just rotate the screen and it's recreating that activity, you've got to go out and get all the tweets all over again. Maybe it's a couple days later and you would have to get them anyway, but we didn't save anything, we didn't persist anything, so we have no choice but to make this request again. So the request comes back, get the same the tweets again, everything's fine. But we wasted CPU, we wasted network resources, we wasted the work that we already did to get information that we may have already obtained because we didn't persist anything. So that's one of the first real problems that the pattern is meant to solve. But there's another issue, and let's say that we have a tweet activity where we want to create a resource in the app, post that to the API. So we create an activity, we enter the tweet, and click send, we fire it off to the API. While we're waiting for that response to come back from the API, we get a phone call. We have no control over that. Now our activity is in the background, or happens in the background. When that request comes back, what happens with the response? Do we try to continue processing that response even though our activity has been paused? Even if we were to try to do that, the Android OS may kill that activity if it needs to free up system resources. And so there's this risk because our activity is in the foreground, it may be killed at any time. Who knows what's going to happen with that response? And it's especially troublesome with a post because we created this resource. We shouldn't attempt to recreate it again if when the phone call is done and the activity comes back to the foreground. So there's this unknown state of that resource from the app's perspective. Another issue is that if you lose a network connection, the app won't even show resources, tweets in this example, that you've already retrieved from the API because it's not persisting the data. There's nothing for it to instantly show to the user. And also give a little more saying, I don't have any network connection, so I can't get more tweets, but I'll at least let you work with the stuff that you got. So the pattern that Virgil gave us is meant to give us solutions to these problems of not persisting data and making things more responsive in the UI and more efficient and just a really solid app. And this is the pattern that Virgil, one of the patterns that Virgil presented. He had two others, and I'll touch on those in just a moment. But this is the one that he spent the most time on. So this is the one that we've been developing. This is when we get to the other patterns, so this is the one that we're going to focus on today. One thing that we wanted to point out in our representation of the pattern is what things the Android SDK gives you and what things you have to roll yourself. And so the things that you see in blue are Android objects. So those are the things that the platform gives you. The things in black are things that you have to create yourself. So let's just quickly step through the pattern and touch on what each of them is meant to do before we dive into the code. So the activity, this is our front-end UI. It makes requests to a service helper, which is supposed to be a simple API. So in this case, it might be get tweet, and that's it. It actually gets the data through the cursor adapter and into the content divider, which is where the data is actually. So the activity makes a request to the service helper to get tweets. It immediately gets back a request ID. So this is an asynchronous process from here on out, but the activity immediately gets back an ID for that request. The service helper's responsibility is simply to package up that request, convert it into an intent that it is going to fire to the service for starting the background processing for fulfilling this request. The service's responsibility is mainly to get the work for processing this request off the UI and then being done in the background on a separate thread. So the service takes the intent from the service helper, unpacks the intent and the data that it received, and finds the appropriate processor for that resource. And so we're representing processors here with a few different boxes to show that processors are typically, or at least how we interpret it, is per resource. So in this case, where you have a tweet processor, you might have a profile processor. So you've got a processor per request. The processor's responsibility is to attempt to mirror the state of the content provider, which is typically backed by SQLite database, to mirror that database with the data that's on the remote RESTful web service. So it tries to make sure that those two are as much can be in sync as possible. So it takes the request from the service, finds the appropriate REST method for that resource, and REST methods broken up even more. So you might have a get tweet, a post tweet. So you've got a method and a resource that make up each of the REST methods. The processor fires out and executes the REST method. The REST method's responsibility is to construct the actual HTTP request. So filling in the headers and the body of the request, executing the request, and then processing the response from the web server. When the REST method returns the processor the result of this request, the processor now has two primary responsibilities. Number one, it needs to tell the activity the result of this request. This is only information about the result itself, a result code, maybe a result message, as little data as possible for the activity to know as much as it needs to know about the stage of that request. So it might be a HTTP status code, an error message, stuff like that. And it just simply goes back to the activity through the callback stage of service and service owner. The other responsibility it has is to put the actual data into the content provider, which will then be accessible from the activity to the cursor adapter. And so the result of the request and the data from that request take two separate paths back to the activity. And so the activity instantly has that data because they can listen for notifications from changes to the content provider. So that is how the path of the data works. Before I get the typical path for the actual data is from the RESTful web service to the REST method processor to the content provider and back up to the activity. For a post, we're creating the resource not only in the activity, but it could happen somewhere else. But we're creating the resource, transferring that state out through into the RESTful web service and then back. Now, one interesting thing about the processor in this case is that because it already has the representation of that resource that we created in the activity, it immediately creates a row in the content provider or in the database for that resource. And it sets two flags. One is the state of the transaction, and so whether we're actually doing a transaction on this resource at this time, or whether we're doing a get or a post, or what information do we have about the state of this resource. And what is the result of the last transaction for this resource? So in this case, when we're doing a post, create a row in the content provider, we say that we're transacting, we're doing a post. We don't yet know the result, so as soon as the result comes back from the web service, the processor updates that resource to say that we're no longer transacting, and here's the last status code from that resource. This pattern, Virgil described as the service API pattern. This is the service is the main API, the main interface that the activity uses. There are a couple other patterns that he gave, and they're largely made up of the same components. In this case, they are. It's just a different way for the UI layer to access the back-end architecture. And in this case, the activity and the cursor adapter only interface with the content provider. And the content provider, depending on how the application works, may decide that it has enough data and it doesn't need to actually make any RESTful request out to an API, or it returns what it already has and then says, well, I better go make sure that there isn't any more data. But this pattern just has the content provider as the main interface for the activity. And the third one was adding a sync adapter behind the content provider. The responsibility is to automatically synchronize the data in this remote service with the local content provider. So in this case, it may not require any specific intervention or activity on the UI layer that the user is taking. It might just automatically. There are tons of benefits to using this pattern. You get more robustness, reliability, more efficient. Not only is it faster, it looks faster, it seems more responsive, the user is not always waiting for the data to load. It's reusable, it's very decoupled. So there's a ton of benefits. But there's a time to learn the pattern and understand how it works. And that's one of the things that we wanted to try to solve in this open source project with the Android user group, is to collectively with the community work on this project and then share the results with everybody so that you can get all of the gains from using the pattern without having to reinvent the wheel yourself. So that's the problem. As I just alluded to, is that Virgil's talk only gave basically what I just said, this abstract pattern, and here's how you should approach it. But you didn't provide any code. That's what we wanted to tackle, and that's what we have. And so I want to hand it off to Brad, and he's going to get into the meat of the code.
So we were trying to think about what kind of application we could build that would be representative of this pattern and also be easy for people to understand. And so we started by building a Twitter app, because that's what you do these days. Twitter has become the new hello world. It seems like it's every example. It's the new canonical. And we knew we were going to have a technical presentation today because people like to see code. And until code starts to look like a code review, then everyone gets really bored. So thought, well, Twitter is the new hello world, and I'm sitting in a technical presentation. The last thing I want to do is look at hello world code. So we needed something else. And we were trying to think about, well, what else do we make? We thought, well, we want something that's relevant to people, something that reflects the important work that we're all doing today, and that can be useful to us. And fortunately, Steve Yegi had the answer for us, and that's cat pictures. So the data speech, you know that the world needs cat pictures, and that today's developers are only more than happy to provide it. So many of you, our premier mobile developers in the cities here, are probably busy building a great cat picture application. So let's get to some code and see how you too can build a great cat picture application. Okay, so you might have figured out so far this is not an Android 101 speech, and we gave this a few weeks ago at Mobile March and had an hour to do it, so we're going to have to go a little faster this time. But I'll try and take you through the high points of what's important in each parts of this application. So to understand how the application works, we're going to kind of keep coming back to this pattern. We'll start with the activity, because understanding the activity and how the activity uses the rest of the pattern really gives us a good idea of why the pattern is developed this way. So like Jeremy said, there's two important parts of how the activity works. One, there's making a request for data, and then there's receiving the data. And this is an asynchronous application. It's event-based. It follows how Android itself works, right? This isn't request response. If you've been building a lot of client-server web apps, this is kind of a new paradigm for you. It takes a little getting used to. But it makes requests through the service helper, and then data just magically appears whenever it's ready through the cursor adapter. So the important things here are a receiver that we have to receive the response from the service helper, and a cursor that we set up that this is the data we want to display. And most of the rest of this is just kind of boilerplate code. For kind of the important part of this pattern is the two lifecycle events, on resume and on pause. So every time your application starts, it goes through a series of lifecycle steps. Most people just deal with maybe either on create or on start. But on resume is really what happens in this case where you got interrupted by a phone call. And then if your app comes back, it doesn't call on create again or on start, it's called on resume. So every time we enter this app, we're really entering through on resume. So the first thing we need to do on resume is figure out what state we were in. So did someone just make a request and that's still happening in the background? Or is this the first time they're coming into my app? I really don't have any idea. So the way I do that is by looking for this request ID. So if it's null, I have not made any requests yet. I have nothing pending or anything, so this is brand new. So the first thing I want to do then is go to my service helper and look for, see is there any more cat pictures. So all I do is I make that request, and like Jeremy said, it just gives me a request ID back right away. Now I have a request ID. It could be that I already had a request in process, and so on resume, when that came in, I can check the service helper and ask, do I have a request pending? And if I do, then I probably have a progress bar that's already spinning. So I just want to make sure that I still set that as spinning when it comes in, so that the user comes back to my app, sees that their request is still going. So now I remember the state that we were in before. That's a good user experience. Finally, if I had a request ID before, so I had made a request, but that request had been completed while I was away, all I'm going to do is just stop my progress bar, because now I know that my request is completed, the data has been updated behind the scenes, and whatever data I'm showing on my screen is the most up-to-date data I have. So I can just simply give her the progress bar alert to the user that they're up to date. So that's on resume. On pause is what's going to happen when I'm about to get interrupted by that phone call, or if you're going to leave. And the biggest thing I want to do is unregister this receiver. So in Android, you've got this life cycle of registering the receiver in the on resume and unregistering on pause, because on pause is really the only event that you're going to be guaranteed that's going to fire for you. Android has a lot of memory management it does for you, and it could decide to kill your app at any time, and the on-stop events don't necessarily get fired. So on pause is a guarantee that you're going to clean up the things you need to clean up, and you're not going to show force closes with receivers hanging out there using a memory. So that's kind of the important pieces here. The last one is this actual receiver that we're talking about. So when we make that request to the service helper, we're going to, the way that it contacts us back is by broadcasting intents. That's kind of the natural mechanisms in Android, is to listen for intents from other services you have. So in this, we're going to listen for that broadcasted intent, and the service helper is going to tell you, or is going to broadcast the request ID plus what happened in every intent. So what you have to do is you're going to receive this and then say, okay, I'm going to get the request ID, and then find out, oh, is this my request? Because it might not be. The user could have been, going through and navigating through your app, and by the time that request is done, they're actually in some other place. It's not the request that's in your current state. So you're always checking if it's the request that this screen was making. And then, if it is yours, we're going to just set the progress bar where, hey, we're done, we received it, we get a result code, whatever it is, and then we can take whatever actions we want based on the result. That would be application dependent. So one of the things you're going to notice in this code is that this is not a very robust application. There's no error handling and there's no logging or anything. It's specifically designed just to highlight the pattern that this is not you wouldn't want to cut and paste this necessarily and just build your app, although it'd be a good starting point. So that's one of the things we wanted to do with this project, was have a very simple application that really just exposed the pattern itself and buried it with a whole lot of other stuff where it was hard to see what was really going on. So that takes us to the cat pictures activity. So let's look now at service helper. Okay, so the service helper, like Jeremy said, its job is that's basically your API. As far as your application is concerned, this is how it gets data. This is how the API is exposed, whether it be Twitter or cat pictures for Reddit. It doesn't know how to do anything other than make calls here. So it doesn't even know that there's a remote service. It doesn't know that it uses REST. It knows nothing except that this is how I access the resources I need. And this is a good thing, because that allows us to be very decoupled. It allows us to decide to get cat pictures from another place at another time, or we can get cat pictures not using REST or using JSON, using XML. We don't care. None of our application has to change until those details. So the service helper provides that interface. Again, this is asynchronous call. So when I ask for get cat pictures, the first thing I'm going to do here is just generate that request ID really quick, put it in my pending request. I'm going to build up the intent, because the service helper understands how to speak to the service. And the way you speak to a service in Android is via intent, and pass yourself an intent. I'm going to start the service with the intent, and I'm going to just pass back that request ID. So it's going to be very quick. So I have to notice the service, I'll give the activity back the request ID. So later on, when this request is complete, I will give them back the result with their request ID. So some of the things I'm telling the service about here are what resource I want. I want the cat pictures resource. What method I want to do. I want to do a get on it. I'm telling the service the request ID that it generated so that we can kind of track this all the way through. And I'm also giving the service a call back saying, here's how to, when you're done, fire this off for me, please. So if we look at what this callback does, this is a result receiver. This was actually one of the difficult things with Virgil's talk, is he kept talking about this service pattern and saying, yeah, you just give it a service callback, and that's how it transmits the data back to the service helper. And everyone started, well, what's a service callback? They're looking for a class called service callback. There isn't any concept in Android, and actually every demo you're going to see out there, and every tutorial never says anything about how to get data out of the service. It's all like, call a service and it downloads music for you. That's pretty much every example, or it downloads pictures. But there's never any response. You're like, well, how do I interact with the service? How do I know when it's done without doing like a bomb service? So it turns out there is this object called a result receiver. It's in the OS, and a result receiver is exactly what Virgil was talking about. It allows you can just give this result receiver to things. It is a parcelable, if you're familiar with Android, and if you're not, none of them are right now. But that's a parcelable is something that you need to serialize like between processes. You need that with intent. So technically, this service can be running in a completely different process. It's called a data center process. So we can give it this result receiver and just implement our on-receive results. So this is actually what's going to fire when the service is done. It's going to fire this off. It's going to give us our original request back. So we bundled this intent together and gave it to the service. It's going to give us that back. So here's your request, and here's the result of that request. So now we can kind of tie those things together. We might just, because this result receiver is just going to get blasted with all kinds of things that happen. It's all asynchronous, so it has to have some kind of context of like, okay, give me this result. What was it for? I don't even remember. Oh, okay, here's the intent that I originally gave you. Here's the result. I can look at that intent and say, oh, that was the request ID I had. Okay, I know what to tell about this. So that's basically service, the service helper. So now we go to the service. That's the next thing. So now the service has a couple of important responsibilities. And that's, Jeremy said, one thing is to get this is where we're going to get this work off of the UI thread. So the UI thread in Android, that's the main thread that's running. And you've got 5 seconds to do your work before you get a pop-up that says you're not responding. And you always want to avoid that. Now, some people mistakenly think that by using a service, I'm automatically on another thread. That's not true. The service itself does run on the UI thread. It just has a separate life cycle than your activity. But there is a way to use services to get things off the UI thread. And in this case, we want to do the simplest one possible, and that is to actually extend this intent service. And what an intent service does is you implement this on handle intent, and Android takes care of already pushing stuff onto a worker thread, and then for every task, it calls on handle intent. So this gives you backgrounding automatically. The only thing here is that you do not get any parallel processing. So you get a single background thread to work on. So it's basically an executor with a single thread. Queuing up all the intents that come into the service and firing out one by one. But this is the easiest thing to do. You can obviously don't have to use this class if you need parallel processing. So now it's done its first task, which is to get this stuff off the UI thread. The second thing is it needs to figure out what processor we use for this request. So now in each step here, we're trying to have each of these pieces only have to know a little bit about, I just have to know how to contact the next thing. That's it. And how to respond back to the contact key. So the service needs to understand which processor to ask for. And to do that, it's going to look at these resource types that came in because there's a processor for every resource. So I can easily ask some factory class, hey, get me the processor for resource type, in this case, cat pictures. The other thing I need to know is, well, what do I want to do with this resource? And So I passed in this method, and so now on a resource I can say, well, I want to get the resource, or I want to post the resource. So a processor has a very simple interface which just looks like the contract of rest, but posts differently. So at this point, even at the service level, we still haven't said anything about REST, really. We just have a processor. We haven't said anything about that this resource comes from Reddit, that we're going to use HTTP, nothing. None of this is exposed. So at this point, your application could work, completely change that stuff, everything still works. So now we get into the processor. The processor interacts with the content provider and the REST method. This is where things get a little more interesting. So far, we just sort of looked at kind of the size and dispatchers, not really interesting things happen there. Now we're going to actually do a little bit of work. So here's my get resource, that's the service call. And the service passed me a callback as well. So this is a pattern within a pattern. So what you see here is that the way that we communicate between these things is to give it a direction, something to do, stuff to do it with, and then something to execute when you're done, a way to call back to me. So that's why this is kind of asynchronous all the way down. So this processor knows how to get the correct REST method. So this is where we're kind of doing the coupling between REST method and the processor here. So it knows that the get cat pictures REST method, because I'm in the get resource. And in this case, this processor, our app doesn't allow you to post a new cat picture. So post is unsupported. But if we wanted to implement that, this is where we do that. So it knows how to execute the REST method. It's going to update the content provider with that information. And finally, it's going to send that result back to the service. And updating the content provider is kind of a simple thing to think. We're actually going to get a cat pictures resource from the REST method somehow. And we're just going to, for each one we get, we're just going to insert those into the database. Processor we'll see in the post has a little bit more responsibility. So let's go ahead and take a look at the REST method, because that's our next piece. Now in Virgil's pattern, he just has this big box that just says REST method. And that was probably half of the time that we spent at that first night going, what the heck does REST method mean? And how do you break these out? And so we took this on as to mean, and basically using cues from the comments he made, that there is some class for each method of a resource. So that's why we have a get cat pictures REST method. There's going to be, it's going to be a post cat pictures REST method. And what the REST method knows is this is to understand the actual semantics of whatever remote API. So in one place now we've combined tying ourselves to, in this case, Reddit cat pictures. If I want to get cat pictures from somewhere else, I change it here, and we're done. It's also test, completely isolated. So that's the idea of the REST method. It knows what the semantics are that's part of the API specifically for this resource and specifically just for this operation, how to get cat pictures. And so here what we've done is template pattern, because there's going to be get cat pictures and get this and get that, and so we're not going to rebuild all that HTTP stuff every time. So there's an abstract REST method. And in the interest of kind of rushing through this, we won't exactly run into all that code, although we'll show you this is open source and you can download this and see it yourself. But it knows the particular REST method has to do a few of the operations of the template. It has to build the request. So in this case, we're building some kind of request for the get and our specific URI. And it needs to know how to parse the response that comes back. So the pattern, the template is going to give us kind of the string that came back from the API. In this case, we know it's a JSON string, and so we can turn that into our cat pictures resource. But that's pretty much the main responsibility of the REST method is creating the request, parsing the response, just like we described earlier. So now we're kind of heading back up the stack, and in this case, the one thing I wanted to point out was that the get cat pictures REST method this execute is actually, this is a synchronous method. Because the web is synchronous and making requests and responses is a synchronous operation. So it's been asynchronous up to here, but now that we're kind of in the REST domain, we do things in a RESTful way. So this is synchronous, this is waiting for a result. But this process is off the UI thread, we have as much time as we want. So we saw where we'd update the content provider. So now we've updated the cat pictures provider here. So that's going to update our cursor adapter. So in a completely separate process, data is getting updated, my screen is getting refreshed. In the meantime, I'm calling back to that service and telling it what happened. So now this is my callback that I made in the service. I'm back in the cat picture service here. And I implemented this send, which is what the processor just executed. So it just executed this method. And all I've done is I've changed this to call this send on the callback that service helper sent me. So we're just chaining these together. So really I'm just passing it right through. So cat picture service finds the service receiver that came in, sends the result code, and also what was that original intent. So remember the service helper gave us an intent to fire us off. I still have that intent, I'm giving it back to them. So here's the request you gave me, here's the result. The processor did the same thing as the service. Here's the request you gave me, here's the result. So it's a consistent pattern of communicating. We already saw this. So here we are on the service helper. It's going to receive that result, and it's going to get that original request. It's going to create a new intent that it's going to broadcast that includes your request ID. This is the request ID that the activity knows about. And what was the result? And it's just going to send that broadcast. Finally, back in the activity, here's our receiver that would have received that. And now we can stop the spinner or show an error if there was some error. Okay, so that's the get. The other interesting one is post because it gets a little bit more complex. But there's a couple, some is the same, but there's a few things I just want to touch on to show the difference. So in our application, which I haven't even shown you yet, maybe I'll wait to see it. It's a big reveal. Nah, I'll show that now. There is a real app. So these are the cat pictures that you can get. This is what we received. And so if I just back out of this, go back in, now I've already got some cat pictures from before, so I can show them. But you can see that I've got a spinner going up here, and it's going to be looking for anything that's new. And if it can get any stuff on our signal here, it'll pull it down. But in the meantime, I've got everything that I'd already pulled, so I'm not waiting for anything. So what we can do now, we want to be able to do a post some way. So we're like, well, what can we do? We can force close. It's not very robust. All right, so let's actually go to one of these guys. So we want to be able to post a comment. And to do that, I can say, and this is what you do with cat picture, you say RQ. That's what these guys want to hear. Oh, demo guy. All right. Well, you're just going to have to trust me on this. What we want to do is be able to post that comment, see our comment immediately, but see that it's pending. And once it's actually been pushed to Reddit, we'll get some indication that, okay, yes, now it's actually there. Right? So this is what Jeremy talked about, is that when we're going through the post, the processor, you have the data actually already. You start with the data. I'm creating it, so we can put it in the content provider right away. We can show it right away. And only after it's somehow been synchronized will we show that, okay, now it's actually up there. So we start with the comment activity here. There's a couple things in the comment box. We actually are showing a list of comments. If there were any existing, we'd see those. Plus, where there's a request to receive comments, plus there's our post. So now we actually have two requests that are possibly going on here. Again, we're setting up our post fields, we're setting up our comments, which essentially is let's set up that cursor to show the comments. And when we click the button, we're going to post the comment. So again, on resume, same pattern. We've got a service helper here we're using. We can call get comments when we first come in, and we're going to get a request ID for that. That's the request is trying to retrieve all the new comments. Similarly, here when we want to go post a comment, we're actually going to call submit new comment on the service helper. This is another part of the API that service helper gives us. And this is going to give us a different request ID. So in our broadcast receiver this time, we would receive some message. So now we've actually made 2 requests, and we can get 2 back at any time for different things. One is hey, this new comment, one would be the result of our post that we made. So if it's our request, if it's the request ID for the getting comments, we can turn off our spinner or do whatever we want. We can also check, oh, is this the request, is this the result of the post I made? And if it is, do whatever we want to do, maybe show a post that the post, there was an error making the post. So this again goes to the service helper, goes to the service, but what's a little bit more interesting here is the processor. So in this case, we're going to post a resource, and this is where it has 2 different things that it has to do. It has to actually first insert the new comment into the content provider. And this is actually going to, like Jeremy said, this time we're going to insert the status column that is a bitmap that can tell us that, one, we're posting, and the post is currently transacting. And then when that post comes back, so we get our post comment REST method, we execute that. When that comes back, we need to update that comment, and then we send back the result. In the update, we are going to just set that transaction is complete, no matter if it failed or not, because the result tells us what happened. So now we just know that the transaction is complete. The result will tell us like the HTTP response that we had. So at any point, the user can completely leave the app, come back days later. We know exactly the state that we were in. We can still show them the last error message they had if they want, whatever we want to do. Okay, so in the interest of only having a few minutes left here, this is the basics of the pattern, kind of up and down and how you navigate through it. The other thing I want to mention is that be flexible. So this pattern, very prescriptive, but it's also not for everything. So it's not just because you're making a REST call with you use this pattern. It's more about I'm making a REST call and there's a state that I want to maintain, and it's something that's really important, or it's data that I don't want to keep retrieving. But there's other REST methods we can make, like a login or something that it's a one-time, and I also probably want it to be synchronous. I'm not going to do anything until I get a response from the log. So something like that this pattern might not make sense. So don't take and go, oh, it's REST, so I use this pattern for everything. There's times when it doesn't make sense for sure. This is where you can get the source if you want. So the Android users group meets monthly, the first Tuesday of every month. And we've been encouraging the people in our group to pull this, fork it if they want to contribute, and send us pull requests. But we'd also like to ask you to do the same thing. So there's a couple things about this project. We have the Cat Pictures app that we showed right now. That's very, very basic. So there's one branch of Cat Pictures, and that intent there is just to demonstrate the pattern. But we also do have a branch for making a Twitter app, and the intention there is not without a Twitter app, but to give an example of a robust, complete application that not only shows the pattern, but other best practices in Android. So maybe it's going to use loaders instead of just cursor adapter, and have good error handling, have a really good implementation of how the HTTP works. For instance, now Android saying go back to using HTTP URL connection, and here's the way to do it. So if there's people that have like, hey, I implemented that, I know how the best way to use HTTP URL connection. Pull this, fix that one part for us, and send us a pull request. That would be awesome. Or just pull it and fix our documentation or whatever, or just look at it and make nasty comments, whatever you want to do. But that'd be great. So this is some resources that you can find. We ask if you want to participate in this, you probably should go watch Virgil's video. Make sure you kind of understand the pattern first. The Google Schedule app is supposed to be an example of this. It's a little hard to find it in there. And that Programming Android book also has an example that sort of touches on this pattern as well. want to thank a few people like Virgil and Steve Yegi for telling us about cat pictures, and Peter Pascale in the middle for being the other musketeer amongst us. Are there any questions in 1 minute? Yeah.
So how do those entries get cleaned up from the database? You're storing every transaction, and eventually you're gonna.
That was asked in the questions after the fact in this thing, and he recommends just a scheduled job that goes and cleans up the old stuff after a while. Your data, it depends on what you store in your database, but I think you get 1 or 2 gig that it could get up to. The SQLite database can handle. So if you're not storing your images there, which you should store RESTful and somewhere else in the file system, you can get 10,000 rows. But most of that stuff, like I said, you would be scrolling through the cat because you would maybe only want the last 1,000 or something. So that's kind of what we recommend there. That's how you can find us, probably on Twitter or something. Otherwise, look for us. Otherwise, we'll hopefully see you at an odd meeting or in the future. So, a little more? Oh, the presentation itself? We'll find out if Minnie's gonna
put it on the MinneBar wiki.
We have a couple images. We just have to see if we have the licensing for. But other than that,
And the everything that we've referenced from the O'Reilly book, the Google Talk, there's links on the main region for the GitHub project. So that's our home page for everything. We've got some descriptions of the pattern, a couple screenshots, but we want to really build that out to have nice and robust documentation.
What license or license are you using?
probably, I'm guessing I'll probably do one of the Apache ones. I think for the Android community, that's a popular one. So the least restricted, have at it.
Great.
Yeah. Thanks. Enjoy MinneBar.